Okay, let me comment still on the notation that I'm using for the full integral. So we have something like this, for example, GL and then G1, and this we want to call the integral against G. So against all those generators collected as a vector. Here I'm not using this empty circle indicating composition, because in some way yes, but in some way we can just skip this notation. What it would mean is that it's actually a composition the way I define this on all of the Grassmann words. So why is that? Well, we saw that the integral GL, so we could say that this is a nested composition of GL minus 1, then ... Then finally, at some point, we are applying G1. And here I'm taking the integral of G mu, some Grassmann word. And for example, here we would have mu prime L, mu L minus 1 prime, or nu if you want, mu 1 prime, G minus 1, and then here I need to close all the brackets. That's what it would mean to have a composition. And for this to work, what needs to happen is that basically composition of G K, the domain and the image, they need to agree. So GL into GL. But we also need to say that sometimes this Grassmann expression will give us 1, which means in some way GL is a span C of all Grassmann words, while this is a span C of G mu, and we are adding some symbol which is the identity here. So now how can I compose GK if it can give me a number? Well, we could extend GK to be acting in this GL extended space, this one here. So how would it work? Okay, so how does it work? We would define it from this extended space to GL, and the definition would be that GK of some number x is just simply 0 for all x in reals. And here I can write that this is this some, because it's a span over complex numbers. So this is actually a complex number here. Let me erase that for clarity. So some complex number multiplying this kind of basis vector, and if it's only that, then the integral is 0. For every other Grassmann word, for example, GK, against GK of GK will give me 1. So that's kind of correct. And then I would say it gives me 1 with this bar, or just a number 1 if you want. And that way we are much closer to having a consistent definition in such a way that I can compose those maps. And then we see that this is what I'm calling in the talk an integral against G mu prime of G mu, and this is non-zero only if mu prime is at least as big of mu. So mu prime equals 1 then mu k is equals to 1. If this holds true, then this integral is non-zero, and otherwise it will be 0. So basically, this is a way of saying that the Grassmann integral is dropping those Grassmann numbers away from the expressions. Then we need to take care of the phase factor, the consistent way of managing the numbers. So so here it's non-zero. Basically, you remove mu prime from mu, and you need to take care of the phase factor the way I was saying before, but you can do it recursively now with those compositions. That's what it takes to go a little bit deeper. But if we want to view Grassmann integrals as linear maps, then on the entire space, I will sometimes get a number or again something in the Grassmann algebra. So I need to somehow either extend it or not if I want to view it as compositions. That's the explanation for compositions. Compositions need that the image is also the domain in a consistent way. Here we want to have all possible orders. So basically the image needs to be the same as the domain, which is this GL space. So this GL space here. And now I have something where I can meaningfully start talking about compositions. But you see that sometimes I will be taking something which is a Grassmann number and drop it to essentially a complex number, something that I would identify with complex numbers. And then I need to say what it means to take the integral here. It means you drop to 0 because the Grassmann number is not there. And sometimes there will be some Grassmann numbers left over. So this is g of eta k prime in this new notation. And this is minus g of eta k prime plus eta j. Okay, so here this is some mu which has zeros, then has a 1, then has zeros, then has a 1, and has a 0 at position k prime and at position j, and then again zeros. Okay, so this is how we can connect to that definition. So sometimes the integral will be dropping still into some Grassmann expression, and sometimes I will need to be able to Grassmann integrate a number which always gives a 0 here. So that's why these extensions, once I have an extension, it is meaningful to say I'm composing those integrations.